Hello everyone. Today let's understand one of the most important ideas in modern physics, the particle nature of radiation. For a long time light was treated as only a wave, right? That wave picture explains reflection, refraction, interference and diffraction quite well. But when physicists studied blackbody radiation and photoelectron emission, the wave picture alone could not explain everything. That is where photon concept enters physics. The key turning point came from Einstein. He proposed that light energy is not spread continuously, but comes in discrete packet called photons. The energy of one photon is E equal to h nu, where E is the energy of the photon, h is the Planck's constant, and nu is the frequency of light. This is very compact formula, but it changed physics forever. Now, let's think about photoelectric effect. Now let's think about photoelectric effect. Suppose light falls on a metal surface and electrons are emitted, as you can see in this image. Classical wave theory would say that increasing intensity should always increase the energy delivered to electron. But experiment showed something very different. Electrons emitted depend strongly on frequency, that is nu, and not just intensity. If the frequency is below a threshold value, no electron comes out no matter how bright the light is. So let's say you have yellow light, and even if it is very bright, there you will not see any photoelectric effect if the work function is higher than the frequency of the yellow light, right? So frequency is the key. Einstein explained this beautifully. One photon transfers its energy to one electron. A part of that energy is used to overcome the work function of the metal, and the remaining part becomes the kinetic energy of the emitted electron. So we write K max equal to h nu minus phi. So here phi is the work function. K max is the maximum kinetic energy of the photoelectron. Phi is the work function, as I said, and h nu is the photon energy. If we define the threshold frequency nu naught by phi equal to h nu naught, let's say this is the threshold frequency, so we can write h nu naught, that is the minimum frequency that is required. Then we can rewrite the expression K max is equal to h nu minus nu naught, right? This formula tells us something very important. Frequency controls the energy per photon, while intensity controls the number of photon. So higher intensity means more electron may be emitted, but not necessarily faster electrons. This is very important. Higher frequency means each photon carries more energy, so the emitted electrons can have more kinetic energy. Now, let us move one step further. If light behaves like a particle, then it should also carry momentum, right? Einstein showed that photon has momentum. So we have heard about this equation P equal to h nu by c, right? So you can simplify and write as h by lambda. Here P is the momentum of the photon, c is the speed of light, and lambda is the wavelength. This is extremely important because it means light is not only an energy packet, it is also behaves like a moving particle with momentum. This idea was confirmed experimentally by Compton effect, right? In Compton scattering, an X-ray photon collides with an electron and the scattered wavelength increases. This change in wavelength is measured using this formula. You may have heard when you are working with competitive exams or so, you may have heard about this formula. Here, the delta lambda is the shift in the wavelength, me is the mass of the electron, theta is the scattering angle. This result is the direct proof that the photon carry momentum, because the shift can be explained only by treating light as particles that collide like billiard balls. So the main idea is this: light has wave property in some experiments and particle property in other. That is why modern physics says radiation have wave particle duality. The wave model explains interference and diffraction, while the photon model explains photoelectric effect, blackbody radiation, and quantum scattering. The final takeaway is simple: light is not just a wave and not just a particle. It is both, and the experiment tells us which aspect becomes visible in a given situation. So think again and read about it. I hope your concept will be clear too. Thank you, and we'll meet in the next video.